Welcome to qnawire.
Okay, we've got some compounds, and we need to figure out what their empirical formulas are, the molecular formula. And I think what's going to help is just counting atoms, right? So we know in the Kekulé formulation, every angled little point or end on a line, that's a carbon, and that we would assume that there are a number of carbons, a number of hydrogens on that carbon, such that the total number of bonds that would be coming from that hydrogen is 4, right? We knew there were 2 hydrogens because there's 2 bonds coming from it, and 4 minus 2 equals 2, so we knew there were 2 more bonds, and they're to these hydrogens, right? So that's the logic we're going to use when we start drawing, counting the number of carbons we have to start, and then figure out how many implicit hydrogens there are. So how many carbons do I see in this structure? I see 1, 2, 3, 4, 5. Okay, so I've got 5 carbons. So I see 5. How many hydrogens, right? Well, this carbon here has 3 bonds, so it must have 1 hydrogen to make 4. Ditto for this carbon. And this carbon has 2 bonds, so it must have 2 more hydrogen. This also needs 2 hydrogens, and we need 2 hydrogens over here, right? So I see 2, 4, 6, 8 hydrogens, and that's the molecular formula. All right, let's continue. This is maybe a tricky one. Okay, let's identify the carbons. There's a carbon here, a carbon here, a carbon here, and a carbon here. So triple bonds act a little differently. They're straight, but we assume that at the beginning and end of the triple bond, there must be a carbon. Okay, so I see C4. What about hydrogens? Well, let's start on the left, right? This has a single bond, so there must be 3 hydrogens. What about this carbon? Well, it's already got 4 bonds, so there's no hydrogens. Ditto for this, no hydrogens, but there are 3 on the end, just like on the other end. Right, so C4H6. Moving on. Okay, well, what do we got here? How many carbons are there? Right, 1, 2. C2. Okay, how many hydrogens are there? Well, there's a single bond here, so we must have 4 more bonds to hydrogen. Sorry, 3 more bonds to hydrogen to make 4. Okay, what about this carbon? Well, it's got 3 bonds already, so add that hydrogen. And then oxygens, we never have implicit hydrogens. If there's hydrogens there, we always draw them in, so we know that there's no hydrogens attached to that oxygen. Right, so I see C2H4. All right, next one. Bromine. Okay. How many carbons are there? 1 here and 1 here, at each angled point. Okay. And how many hydrogens are on this carbon? Well, it's got 1, 2, 3 bonds, so it needs 1 more to make 4. And the same for the other carbon, it needs 1 more to make 4. Okay. So I see C2, H2, and there's 2 bromines, so we just say Br2. Okay. Usually if there's atoms that aren't carbon or hydrogen, like bromine or oxygen, we just tack them on at the end, right? Okay, last one. Okay, how many carbons are there? Well, there's 1 here, and 1 there. Right, so I see 3 carbons. C3. How many hydrogens? Well, let's go to each of the carbons and see how many hydrogens they have to make 4 bonds. This carbon has 1 bond, so to make 4, 1, 2, 3 hydrogens there. And the same for the right-hand side. We need 3 more hydrogens to make 4 bonds. Okay, and the central carbon already has 4 bonds, right? So it doesn't have any hydrogens. So I see a total of 6 hydrogens. And what about chlorines? I see 2 of them. All right, there we are.